Okay, so using the reciprocal, before we solve equations with multiplication and division, I want you to think about what division is. Right? Division is when you break something into smaller parts, right? So division is when you are turning something into fractions, right? We're breaking into smaller parts, we're fractionating it. So therefore, division is actually the same as multiplying by the reciprocal. Okay, so we'll do a little example. So I want you to think of, so if we have x divided by y, and I'm going to use the old way just for example's sake, and then we have x times the reciprocal of y. So, right, we have divided by y, or I can multiply it by the reciprocal, right? Because division is the same as multiplying by the reciprocal. So the reciprocal of y, right? If it helps to write it like that, the reciprocal of y is 1 over y. Okay, so if you remember, we actually write our fractions like this, x over y, right? Write our division like this, x divided by y, so we're going to write it as a fraction. If we wanted to multiply this out, and if it helps, we can, turn any number into a fraction. I multiply the top, so I get x times 1 is x. Multiply the bottom, I get 1 times y is y. And look, it's the same thing. So we went from here to here, and we got the exact same answer. Right, let's try this with numbers. So maybe I have 16 divided by 2 is equal to 16 times 1 over 2. Okay, I'm going to write 16 divided by 2 as a fraction. If you plug 16 times 1/2 into a calculator, you should get 8. Okay, so you'd plug that in. You get 8. 16 divided by 2, what is that? That's just 8. Right, so we just proved that division is the same as multiplying by the reciprocal. You're probably thinking, okay, why does this matter? Right, this matters for when we start solving equations. Okay, so first of all, the things you want to remember is this rule that division is the same as multiplying by the reciprocal. And you also want to remember that when you multiply reciprocals together, right, so like 1/2 times 2 over 1 equals 1. Right, so these are the two key things you want to remember, because now we're going to solve equations. Okay, so let's say we have this equation, 3x equals 72. I want to solve for x, right? I'm trying to solve it. I have an equation. That means I have enough context. That means I can solve it. So I need to figure out what that x is. In order for me to do it, I need to end up in some kind of x equals, a number. What is this number? That's what we're trying to figure out. Right, that means I have to get x alone. Right, so if you remember before, we did maybe an addition one. We got x alone by getting rid of the 2. Okay, in this case with addition and subtraction. And we solved for x. Okay, so here in this example, I want to get rid of that 3. Right, but what am I trying to replace the 3 with? If you look here at x equals 2, oops, sorry. So do you remember the identity property? So I'm leaving kind of a gap here for our problem. So the identity property. The identity property is, right, any number times 1 is equal to the number. Oops. Right, so that would be like 5 times 1. Oh, sorry. Where's my undo? 5 times 1 equals 5. If we have a variable, x times 1 is x. Therefore, you could rewrite this, the commutative property. 1 times x is equal to x. So in essence, when we solve this, we're actually solving for 1x equals 2. Right, but we usually don't write that 1 because it's just kind of like, it's redundant. Like, of course, 1 times the number is just its number, so I don't need to write the 1 there. But I just want you to remember that, because if you remember this rule, when you multiply reciprocals together, you get 1, and we want to end up here in this problem, we want to end up with 1x, not 3x. We want, sorry, that made it look like a negative. Not 3x, we want 1x. So, knowing that rule, I can get rid of the 3 by multiplying by the reciprocal. So what's the reciprocal of 3? 1 over 3, right? And then transformation, if I'm going to do it to the left side, I also have to do it to the right side. Okay, and so if you think of this as like over 1, we get, I want to erase this first. We get 3 over 3 times x, and then 72 times 1/3, you plug that into a calculator, you will get 24. But then what's 3 over 3? That's just 1, right? Which is exactly what we want. 1 times x is 24. And because of the identity property, the 1 is redundant. We don't actually need to write it. So x is just equal to 24. So we just use these properties. We use this property right here to solve for x. So let's just do some examples. And I'm going to show you there's actually a different way to think about it based off of that first rule. So we have 24, 2x equals 24. I need to get x to be by itself 1x, right? That means I have to get rid of that 2, right? So 2 times x, the way I can get rid of 2 is by multiplying by the reciprocal, which is 1/2. If I'm going to do it to the left side, I have to do it to the right side. Whenever you multiply reciprocals, you just are left with 1. The x stays there. 24 times 1/2 gives me 12. And so we get x equals 12. Okay, so we also talked about that division is the same as multiplying the reciprocal. Why does that matter? Because we can solve this a different way. So depending on which way, you might like it this way, or maybe you will like it this way. So if instead of multiplying by the reciprocal, I'm like, you know what, I don't want to multiply the reciprocal, I want to divide. So let's just divide by 2. Instead of multiplying by 1/2, I divide by 2. 2 over 2 gives me 1, right? That leaves me with 1. So 1x, 24 divided by 2 gives me 12. This is technically actually the exact same thing as up here. It's just kind of a different way of looking at it, but you're still, because if you wrote this out, right, and then we multiplied it out, so then we get 1 times 2x is 2x over 2. 24 times 1 is 24 over 2. It's actually the same thing, right? So it's just kind of, instead of multiplying the reciprocal, you can kind of skip a step. It's not quite skipping a step, it's just moving on faster. And just think of it as dividing instead, because dividing is the same as multiplying by the reciprocal. So we'll just do examples and we'll solve them both ways. Okay, so I can do the reciprocal way, right? Because I know that's just going to give me 1 leaves the x, 36 divided by 4. Wow, I'm having like a brain fart. Is that 8 or 9? I'm gonna need to get my calculator. Oh, I forgot, I'm not on my phone. 9, right? If I'm wrong, I'm so sorry. It's late. Right, so you do it that way, or we can do the... Yeah, it's 9. Okay, I don't know. Or we can do the division way. Right, divide by 4. That gives us 1 there. So x equals, and then 36 divided by 4, 9. Right, you're going to get the same way either way. So I'm just doing it both ways, just so you can see which one you prefer. Okay. Okay, so the reciprocal way could be like this. One 12 times 12 is 1. 60 times 1/12 is 5. Or we can do it this way, where we just divide both sides by 12. Get 1. I prefer this way. That's just but it's just how my brain works. Maybe you like this way. Yeah, but lots of different ways to do it. So now I want to do a little bit trickier ones with some fractions. So let's say we have 1/3 x, which would just be 1/3 times x, equals 12. Okay, so this time it's a fraction. Same process though. I'm going to multiply by the reciprocal. This is one where I wouldn't recommend doing it this like second way, because then you're going to get like 1/3 divided by 1/3, and it starts getting like you're dividing fractions by fractions and fractions, and it gets like really complicated. So I just stick with the reciprocal way this way. Okay, and then we're left with 1 on that side. 12 times 3 is 36. Right, because like if I write it out again, see, if you tried to do the other way, then you're like divided by 1/3, divided by 1/3, and it's kind of just like, how do I plug that in a calculator? And that's complicated, right? So when you start out with a fraction, like over here, they start with nice whole numbers. Here we're starting with a fraction. Just do the reciprocal way. I think it makes it a lot more easier. So if you look at that one, I just want to rewrite it, the original problem. Okay, so you might see it written like this, or, and let's remember you can write this as a fraction, you multiply tops and bottoms. It might look like this. Okay, that's the same thing. These two are the same. And we'd solve it the same way. The way I like to think about this one is, I'm trying to get rid of this 3. I'm dividing by 3. What's the opposite of dividing by 3? Multiplying by 3. Okay, and then I will get 3 over 3, right? We get 1, we get x. We get 36. So again, if you see something like this, I'm dividing by 6. What's the opposite of dividing? Multiplying by 6. So I'm going to multiply both sides by 6. I'm left with x and 12 on that side. It's a really good way to think about like these. So if I rewrite that one, some students think of it better this way too. It's 12 times x. What's the opposite of multiplying? Dividing. So instead of multiplying by 12, let's divide by 12. right? So that's how you should, that's one way you can think about it, like, okay, I'm multiplying, the opposite of that is dividing, so that's how I'll transform. Okay, this one, I'm dividing, the opposite of that is multiplying, that's how I'm going to transform. Okay, it's big numbers, but that's okay, that's what calculator's for. You still know how to do all the steps to do this, right? So we're dividing by negative 25. Instead of dividing, I want to be multiplying. So do it on both sides. That gives me 1. 18 times negative 25 is negative 450. Or if you see it this way, same concept. I'm going to multiply by the reciprocal. Left with 1 on that side. And then negative 450. So this negative sign is important. Something I forgot to mention, right? I don't want to, if I forget the negative sign, let me just do another example. So let's say we have, let's make it small. Okay, let's say I multiply by the reciprocal, but I don't keep the sign. What is 2 times negative 1/2? You're still going to get 1, but it's a positive times a negative, so it's going to be negative 1, right? So we're going to be left with negative 1x, and then I multiply this side by 2, right? Equals 4. You don't really need the 1. It will be negative x equals 4. But we're not solving for negative x. We want to solve for what x is, not what negative x is, right? That's what our goal is. So it's really important that when you do reciprocal, reciprocal means the sign stays the same. Reciprocal is not an opposite, okay? Reciprocal is just an inverse. That just means you flip it. So the sign should still be the same. Okay, so then we have negative times negative. That will give us that positive 1 like we want. 2 times negative 2 is negative 4. That's what we want. We want to know what x equals, not what negative x equals. And if you do accidentally do it this way, this is not the end of the world. We can fix it. How do I get rid of negative 1? Let's just multiply by negative 1. And we do it to both sides. Negative 1 times negative 1 is positive 1. 4 times negative 1 is negative 4. And I still got the right answer, right? It's the same as down here. I just find it's easier if you just do it in the first step immediately. Do the true reciprocal. Right, but if you don't, that's okay. You can always still solve it. All right, so that is solving by multiplication and division. So now we will move on to multi-step equation.